All right, welcome to WP Radio. I just wanted to let everybody know this is a recorded segment from WP Radio Live at the OIAA Claims Conference in January 2019. I hope you enjoy all the different little elevator pitches from all the companies. So sit back, relax, and enjoy it, and we'll see you soon. It's Terry Doherty. We're live here at WP Radio, and we're live at the Metro Convention Center as part of the Claims Conference. And right now I have Dr. Alan Morris, and he's from Roar Engineering. Welcome to the podcast.
Thanks for having me, Terry.
So, Dr. Morris, tell me about Roar Engineering. Tell me what you guys do, what you specialize in, and why you guys are so good.
Okay, so we're a forensic engineering firm. We are multidisciplinary, and we can cover the country. And we do fire, electrical, environmental, structural, collision reconstruction, biomechanical. Think that's pretty much it. And we entertain all sorts of investigations that are really issues, even chemical, product failure, materials, and flooding, etc.
And you're based right here in Toronto in the GTA.
We're based in Mississauga, right near between the 401 and the 407.
And you have one office here in Toronto?
We do, and we have a branch in Vancouver.
Okay.
Victoria.
And any out on the East Coast at all?
Nothing on the East Coast, but we travel at the East Coast
sure.
too. So we can cover anywhere in Canada.
Excellent. And Roar, I remember them as being Roshan, and that's right. Kind of its predecessor.
Right. So Roar has been around since 2015.
Yep.
And prior to that, the Roshan brothers, Vince and Michael, they started Roshan Engineering some time back many, many years ago. And that was eventually sold off. And they continued to work at, it used to be called Roshan, and then has changed over to Perio.
Yep.
And then they left the business for a couple years, and they decided to get back in and start up Roar Engineering.
Excellent. And it's still owned by the two, right?
Yeah, principally owned by the two.
Excellent. And you've come on board in the last year?
Yes, I've come on board. So I manage the collision reconstruction and biomechanics area. So I am involved in all aspects. So we do things such as all sorts of collisions, motorcycle, pedestrian, cyclist, heavy vehicle, regular car, SUV, pickup truck sort of collisions, those that involve injury analysis as well. And I also involved in the biomechanics area, so slip and falls, as well as the injuries that happen in motor vehicles.
And my favorite topic, which you hadn't even brought up, AI. Autonomous vehicles.
Yes.
So tell me something. We can go back and talk about all the other stuff, but tell me what's new and exciting in AI.
So I've been investigating autonomous vehicles from a perspective of what's coming down the road, because as collision reconstruction engineers, we have to be ready for what's going to come in the future in terms of how will we be investigating it. The autonomous vehicle sector is continually changing. Sometimes it crops up in the popular news, other times it's just in industry news in terms of manufacturers rolling out new updates on certain vehicles, whether so you've got some major players in North America that are doing it, as well as Tesla, obviously, but Volvo, GM, Audi, they all have various elements. So the Society of Automotive Engineers has a classification of 5 levels of autonomy, and the 5th level is that self-driving vehicle that does everything for you. But those vehicles, those completely self-driving vehicles, are not currently on the road. What you have are different levels of autonomy, and you'll see them in a lot of vehicles that are out today in 2018. They'll have lane change assist. Some of them will make you aware if there's an imminent hazard. Some vehicles will take over if they see that the sensors indicate that you're yawing out of control. kind of gear down the wheels of various tires so that you can maintain stability. Others are like fleet following, so on a highway, maintain a certain distance between vehicles.
So many chevrons apart,
so
right?
many, like a 2-second or 1.5 second following distance. Other vehicles establish, they take over if there's an impending collision. They basically, if your vehicle is a combination of certain speed and distance, coming up to a following vehicle, whether it be stationary or just the speed difference between the vehicle ahead, that it's going to hit the brakes if it believes that you're in imminent hazard of colliding and that you haven't taken any action. So there's also all sorts of things that are currently available on vehicles. Obviously, the gold standard is to move ahead towards complete autonomy. That's coming, but what's happened is you've seen some major headline-grabbing collisions that have happened where the vehicles have failed to detect either a pedestrian.
That one in Texas, where it hit the guy at night. It didn't detect him.
I think it was in Arizona, but
Yeah.
And then there's the major Tesla collision where it failed to see a tractor semi during the day. It mixed it up with the skyline. So all of these things are sort of setbacks to an industry because they're attention grabbing, but ultimately, if you look on a statistical basis, these vehicles will ultimately be safer than humans driving. But to get there, there is going to be some failures along the way. And so the question is whether investors will lose confidence or the manufacturers they're not willing to take on all liability.
Yeah, I heard Uber was even talking about moving to the autonomous vehicles, so they would literally have a fleet of their own vehicles with no drivers.
For sure.
So they didn't even need to pay a driver at this point.
Yeah, they have been, I think it's in Arizona they were doing that trial.
Yeah.
I can't remember with which, if it was with Volvos, I can't remember. But that's definitely something on the horizon. They're trying to, their business plan is to cut costs.
Sure, right?
Maximize profits and cut costs.
Well, also they eliminate the problems with they've had some headline news with regards to, drivers assaulting people and having arguments with patrons in their vehicle.
Yes.
If you don't have a driver, you don't
Yes.
have that issue.
No risk of personal injury. Sure.
Right? So, it's just I find that every time I, watch 60 Minutes or one of these headline shows, there's something new on the horizon with autonomous vehicles. And I love talking to you about it because I know you're on the edge with it.
Yeah, there's so in the U.S. there's been trials with tractor semi-trailers. I believe it's Las Vegas, the state of Nevada. They have allowed tractor trailers on the roads that are in autonomous mode or semi-autonomous mode. I mean, ultimately, if you're a trucking company, you're interested in taking the equation of a driver out of the loop because you could be transporting 24 hours a day.
Well,
vehicle.
the only thing they do is stop for gas, right?
Right.
And then you can have that put into your driving parameters that, they stop at X gas station and that gas station knows
Right.
when your truck comes in, they're to fill you and they bill based on that vehicle, right?
Right.
I mean, how great of a that's just such a great business model.
Yes. So the challenge in the whole autonomous vehicle sector is really establishing the safety of these vehicles. So one problem is that from a technical point of view, when we, if you look at medical devices, they are, the testing and the rigor that goes into testing a medical device or a treatment before it's open to the public is quite significant in terms of animal models and other models. And the problem is that there's no standardized testing regime for autonomous vehicles across different companies. And within a company, there isn't it's not possible. So if you think about a car manufacturer has a 2 or 3 year cycle between the next version of their vehicle. And the reality is to establish, say, a 1 fatality in 100,000, you would need to have continuous testing of, say, like a fleet of 100 vehicles over a 10-year period in order to get the number of miles to establish that one fatality in 100,000. So the reality is vehicles are going to be deployed without the level of assurance that we would expect in the medical industry.
Well, okay.
Right? So it's something to consider as an insurer of underwriting that.
Now, when you're investigating these types of cars that have levels of autonomy 1 through 3 is typically what we're seeing, right?
Yeah, close to 4.
We're getting close to 4 now?
Close to 4. There's some times when you have on the highway automatic lane changing. You can put it in a mode, I can't remember if it was the Cadillac CTX, that you can actually have it go on the highway and it would go into fleet mode and it would change lanes for you and it would automatically go on the off-ramp.
Yeah, slow down, speed up.
Yeah.
Yeah, there was one of the commercials of one of the car guys was saying he literally put it in that mode and he just put his GPS in where it went,
Right.
and he sat back and the car literally drove from point A to point B for him.
Right.
Which I find is unbelievable. But he was there and he was well awake and alert, but he was just pointing out that this vehicle does this for you.
Right, it's capable.
Yeah, but there was a cost involved with that, obviously. But, in the general everyday, A to B cars, we're seeing what, level 1 to level 3 and now level 4?
Yeah, probably 1 to 3.
How do you go about investigating those? So when you get into it, when you're looking at accidents, when you're doing a download of data, does the data tell you that it was in whatever mode?
No, the data might tell you that cruise control was on.
Okay.
The data might tell you that it was in a certain mode. We have to look at really from an insurer's point of view. What does the user manual say about this vehicle? That's the first level, and then you'd have to go into the service manual to establish. See, the problem is these cars are built on hardware, which is all the sensor, and then they're built on a lot of software. And the software is all proprietary. So the actual code that goes into programming these cars and allowing them autonomous modes are proprietary. And you'd have to get a court order to allow us to be able to see those, and then figuring out those programming loops, where if there's an error or what's the sort of logic that's going on here. And so ultimately, if we were to investigate one of those things, you need to know the snapshot of what all the sensors are gathering, what was the status of the vehicle, and then what happened in the last 30 seconds leading up to the collision.
So is this making your job as forensic engineers harder with all this new technology?
Well, yes, because it's a question of accessing that information, and that's going to be challenging. And then because a lot of it's going to be proprietary, whereas you have EDRs, there's a certain standard of download of that information, and you can see the status of those vehicles, but it's sort of like a 10-second window before and after a collision, but it doesn't really tell you the logic and the software programming that's gone on. And the problem is with the autonomous vehicle, it's a matter of what are the sensors measuring, or what did they miss measuring. And so essentially to reconstruct the collision, you have to establish all of what the environment was, what the sensors were measuring. Did the program fail to analyze the information properly, or was it a failure of a sensor without a redundancy in place to have caused this problem?
So there's a lot more going into your investigations than the typical drag sleds that you used to have back in the day.
Yeah, it definitely is going to get complicated.
Yeah, it sounds like, and especially with a lot of proprietary information being attached to these downloads, because I remember there was a lot of pushback when people were starting to use the downloads originally, and then they seemed to give a little way. But now with the technology, I'm sure they're not going to be wanting you to get that much farther into the data that's in their cars.
Right. This was a problem, if you remember the Prius issue of many years ago when they were talking about the Prius accelerating on its own.
Yeah.
they had to essentially, I think it was the National Highway Traffic Safety Administration, had to go in and get access to all the code that went on and try to establish was there any software programming issues that could have caused this problem. Aside, people think, well, it's a hardware issue that it's allowing the vehicles to accelerate. But now that you have things that are, the system of these Priuses, there's a lot of electronic software-generated control that's gone on. So it's essentially fly-by-wire.
Well, that's what I was just about to say that exact term, because that was the Hyundai also has that in their ignition or their throttle control as well.
Right.
And they were having a lot of problems because I remember a specific claim that they were having where the car was speeding up and slowing down on its own.
Right.
One specific car, and they were trying to replicate it in another identical car, and they couldn't. Right. So they knew it was a software issue.
Right. So fly-by-wire, for the audience that's listening, is when there was not a mechanical connection between the driver and the transmission, and essentially you have a layer of software in between that's controlling the throttle.
So it's a computer, basically.
Yeah.
You push the pedal, and the pedal sends a signal to a computer, and the computer sends it to the ignition and tells you to go faster.
Right.
Or slower, or whatever it is, if you decelerate. But this problem was in this car, and again, it's really interesting that, it's not just the Prius, it's other cars, and I think it's going to get more problematic as we get into, I was watching a TV show, and I know it's only TV and it's the movies or whatever, but it was somebody was able to download a virus into a car and cause the car to drive with their controls, like take over the driving ability of another car.
Well, it is possible. I think there was a well-known Wired magazine actually established that they could take over control of a car remotely, the acceleration of a vehicle and the stopping of a vehicle.
Well, this is what this was all based around, and they were causing people to drive into intersections, causing fatalities, right? So then they were trying to track down the perpetrator or whatever. But so you're saying it does actually assist the ability to do it.
It is possible. Yeah,
wow.
Hackers have been able to establish that. So the question is, this is the problem with these, quote, smart vehicles that have essentially internet connection or OnStar connection, etc. If hacking is possible, then you have remote access to a vehicle's control.
Wow, okay. So you at Roar, you're able to go in and see if that's, or is that something you could see if somebody, claims the car drove off on its own?
Yeah, we have, as part of Roar Collision Reconstruction, we have access to a new system called Burla. So Burla allows us to do the downloads of infotainment systems. So that allows for downloading information associated with the vehicle's control. So we have not only the speed and the status of the vehicle, but also Bluetooth and GPS data, other sorts of access that's allowed by users. So we can find out things that are associated with alibis about how the vehicle, whether it was out of control or this was a made-up story.
Well, and it's funny, you said a word, and I hadn't heard it in a long time, yaw.
Right.
Yaw. So for those people that don't know what yaw is.
So yaw is when a vehicle is sort of spinning out of control. So usually when you're turning, trying to cover a curve, navigate a curve, and you're going too fast, all of a sudden your vehicle, say it's a right turn, your vehicle may begin to spin clockwise because your vehicle can't hold that curve radius at that speed. And so the the tires start to side slip, and you begin to spin out of control. So that's termed yaw.
So you can investigate yaw to find out basically what speed they were taking that corner at, right?
Right. So it's a combination of the radius of the curve, the friction that's available at that time. So that's the tire ground friction. So it'll depend if it's raining, slush, snow, ice, etc., dry, whether these were winter tires, summer tires, etc., and the speed.
And you can bring that all, so you can look at all of that and determine this person, so on an off-ramp when you're doing, it says 30 kilometers, and they say, no, I was doing 30 kilometers, it was dry, I don't know how I ended up on my roof in a field.
I have that exact file that I'm investigating.
Yeah, absolutely, right? That's the classic, I have no idea how I ended up on the roof in my field, and now I've got an injury, so now you're going to pay me for my injury and my car.
Right.
And you guys go, hey, hang on, this isn't possible. If you were doing 30, even on a wet road, you wouldn't ended up in the field, right?
Yeah, correct.
So how do you go about investigating that?
So there's potentially tire marks available to us that the police have taken photographs of. They may if there was a fatality, they would have taken detailed measurements of the tire marks, etc., and where the vehicle ended up. Otherwise, we may just be left with a few photographs, and then we have to try and establish what the path of that vehicle was. We can then say something like Google satellite view, we can establish the radius of curvature of that roadway. If it was on something like the 407, we can establish their average speed prior to the getting onto the off-ramp. And then we use that.
How can you do that?
Well, so the ETR has records of when they entered and exited the 407.
And you can tell the distance for time of travel, right?
Yeah, we can tell. So we can establish the average speed. So it doesn't give us the exact speed at exiting, but it tells us if this individual was driving at a high rate on average. And then the next part is, okay, so we can use momentum-based physics to establish, and we know, to say it's a dry day, and we know what tires they were using, we can establish what's the likely friction coefficient. So we could establish, if we know the curve, we know the path the person's taken, we can simulate how a vehicle, at different speeds, how a vehicle, could it handle the curvature or not, and then at what speed it lost control. It would have lost control.
And so and you do that as a physical finding, like you actually go out and you do all those, tests and that information, and then you can also do the download to verify that data is correct?
So sometimes, like in the case I'm dealing with currently, there was no download available. It was an older car, maybe mid-2000s, no download available. So then we have to rely on this secondary analysis to establish speed.
But in the case where there is the download available, you can use it and say, listen, not only does the download say it, our actual data that we gathered says the same thing, so we have verifiable data, correct?
Right. So sometimes it's complicated when you have a collision that may have been on icy road where there's slip involved with the tires, between the tires and the ground. So sometimes the wheel speed may not indicate the actual speed of the car. So you may have braking that was recorded on the download, the black box or EDR, and that braking may not have been present, because what happens is on an icy road you can actually brake the vehicle and create wheel lock, but effectively you're not slowing down.
Some cases you're going faster.
Right.
Okay.
Right.
Well, Dr. Morris, it's always interesting talking with you. I enjoy it. I immensely enjoy it. I know our listeners enjoy it, and I appreciate your time. And hopefully we'll have you back on again. And thank you very much for your time today.
Thanks for having me, Terry.
And how are they going to get in touch with you at Roar? Let's get your contact info.
So you can reach us at www.roarengineering.com.
And if they were going to phone you, toll free, or is there a 416?
Yeah, there's a toll-free number, 844-235-8565.
Excellent. And if they're looking to reach you directly to talk about OIAA or all sorts of things, how would they reach you?
So you can reach me at that number at extension 204.
Excellent. Well, thank you again, and we appreciate your time.
Thank you very much, Terry.
Thank you very much for listening to WP Radio Live. We appreciate your time and listening to the podcast, and check back in a few days as we'll have another one coming out.